if mass m is the mass of an electron, c is the speed of light, the ratio of wavelength of a photon of energy E to the electron of the same energy is, okay. Question says, if m is the mass of electron and c is the speed of light, then what will be the ratio of the wavelength of a given photon with having energy E and the electron having the same energy E? We know that energy E is equals to h nu for a photon. Yes, from dual nature we know this, E equal to h nu. Even from 11th standard structure of atom, this will be hc by lambda, that will be your energy, E equal to hc by lambda. So what will be the wavelength? The wavelength of the photon will be equals to hc by energy, equation 1, correct. And what will be the electron's wavelength? Electron's wavelength, now you can't use the same formula, okay. Why? Because we have to use the wavelength of the electron that we have done in our de Broglie wavelength, if you remember. So de Broglie wavelength says lambda. Sir, why can't we use this? Because c is the speed of light. Be very careful. C is the speed of light. That cannot be used in case of electron, because electrons move with a speed less than the speed of light, right? Speed of light is maximum. Everything in this universe moves less than the speed of light, right? So you can't use the same set of relation. So lambda E is the wavelength of the electron, that must be h by momentum p. And from 11th standard we know that momentum is nothing but root under 2me, 2m mass of electron into energy, correct. Now this is equation 2. Let's divide equation 1 and equation 2. So when you divide lambda photon upon lambda electron, wavelength of photon to the electron, then dividing, it will be hc by E into root under 2me by h. This cancels with this. We left with how much? We left with root under E, no? So that will be c times root under 2m. I cancelled one of the E with one of the, so root. So this you left with lambda p upon lambda E. So c outside 2m upon E. Is there any option? Yeah, option A.